All right, it is recording. Good. So ideally, these kind of models, what we do is this is our main model, let's say. This is my main model. And along with the main model, I will have, let's say, small learning in some form, right? This is learning one will be just available to for customer one. This is like custom add-on for customer. So in basically in Avneer, what we used to do was these add-ons, we used to first we were storing them in JSON format, and then we converted into some numbers format so that it can directly go to database like MongoDB and such. Right. So then every customer was being like this customer, this was a small add-on. So let's say customer C1 comes and C1 tries to access this, and immediately he will see his own version of model. That is, model is pretty much same, but along with this add-on, right, or specific configurations, he will see completely different behavior. So the customer will feel like he's getting that specific model as per his requirements, and this is usually happens for everywhere. Even for Salesforce or everyone, they will be hosting one model, and with that one model, they will have configurations specific to customer or user. Now, when the user comes in, the model will pick up those configurations or preferences, whatever we call it. And based on that, those preferences, the slight behavior of the model will change. Let's say I want to see something else. I say that a very common scenario is that since everyone might not understand what is an obligation. So in legal contracts, basically what happens, let's say if there is a legal contract and there are various kind of conditions that customer puts into. I mean, when you sign an insurance document also, right? There are various things that if you do not do this, this will happen. If you do not do this, this will happen. And basically when any this obligation is breached, it usually results into fine or something like that. So like it can be fine or termination of agreement. So basically AI automatically goes and detects these obligations. Now customer C1 might say that my obligations are different. Customer C2 might say that my obligations are different. So it will extract different set of obligations for C1. For C2, it will extract different set of obligations. Even what we did was for C1, it was extracting all the service level agreements, all the SLAs, basically it was extracting. For C2, it started extracting completely different obligations. I mean, they were related to energy and solar and everything. So it was same model, but just the behavior of the model was changed. I hope that answers your question, Vikram.
Yes.
Right. Yeah. But yeah, if the customer is very like stubborn on the point that no, I do not want even this thing, then if he's paying enough, then we can isolate the model for him. All right. So today what we start with is we start the whole story of how the model learns. And then this is an applied AI session, although I'm going deep into how the model usually works. But once we see how the model works at L1 levels, we will see the visualizations. So this was my whole point, that I want to bring visualizations so that everyone can see how the model has been working, training and learning. Then basically we will eventually pivot to applied AI, that is applications of these models basically. In this session only, I have provided one exercise also. Now that exercise, what we are going to do is with that exercise, we will learn that what is going on. Basically, it is a step-by-step instructions of how we should be learning, step-by-step instructions of each and every command that you have seen, so that it's a hand-holding kind of session. So you don't have to face any ambiguity or any confusion on that. So I'll quickly start on this. But before going further, a small amount of revision is definitely needed. This is the neuron, basically what we have been talking in the past 6-7 hours that we have. This is what we have is just a second. Right. So we have been talking about a neuron. Now, neuron, obviously, I'll just give a small recap and then we will come back to the same lecture once again, maybe. Oh, yes, basically. Okay. So I have also I included few slides from previous lecture also. So what we did revise was basically the problem solving. This is a pattern-based problem solving field where we are trying to solve any problem by finding the individual patterns. And the nature, we live in such kind of nature that everything has patterns. In fact, this is how nature also solves any problem. Nature does not solve problem by approximation. That is, it does not have approximate solutions for anything. It keeps on evolving from small environment decisions and everything, and then it keeps on evolving, right? So if every factor becomes a learning part for environment, for human gene, and this is how evolution takes place. Everything is, it evolves, at least in living cell, trees, animals, everything is evolving. And it is basically learning the patterns, whichever patterns are affecting the nature, and then it evolves. So last session, we had a look at the problem that how Jim Simmons and resonance technologies, basically they were able to find sophisticated patterns they performed some sophisticated study on the market, and then they were able to find some sophisticated patterns they were able to study and then mint money out of it. So this is a pattern based field, again coming to revision, that first point being this is a pattern recognition field. Right. Second, how does either what you can do, this is a pattern recognition field, either we can learn anything, right? The point being that there are a lot of ways you can detect pattern in different kind of data. Let's say if you have tabular kind of data, then you can have different algorithm for that. Or let's say if you have series data, now weather information is series data, that is, it depends on a time. So we call it series data. Then you will have to select a different kind of algorithm. Or you can use deep learning. That is one solution for all, right? You can use deep learning. These deep learning solves all of your problems. I mean, the same framework for solving all of them. But having said that, it doesn't happen that you use the same neural network for solving all of the problems. Obviously, there will be different arrangement. The arrangement, I mean, for one problem, the arrangement will be like this, this will be the arrangement. For another one, I mean, the arrangement might change. I mean, it can have these kind of arrangements. So now the whole point being, our whole study is going to be understanding of arrangement of the same neurons, right? Going back to the same thing, that what was a neuron? So deep learning, use of deep learning for solving all kinds of problems. We solve all kind of problem using deep learning. What is deep learning? Deep learning is basically the science of weight adjustment. It is the science of weights adjustment. That is, we have weights and biases, and these weights and biases keep on learning and they keep on evolving. Now, again, coming to the same point, that what were weights and biases? So basically, today we'll have a live demo. We see I prepared some visualization, posted it on WhatsApp also. And I have few more visualizations that we'll see, like that will help you in understanding this thing better. Now we have these neurons. A single neuron, basically, this is an input, I1, I2, and I3. And all of these have certain weights. W1, actually, one can have multiple weights. Then W4, W5, W6, and W7, W8, and W9. And then basically what happens, there are multiple neurons. More number of neurons, more learnable it will be. The less number of neurons, it will learn basically less number of patterns. And then we have an output, right? Now we will again understand the same theory. We will be actually reiterating the same theory today, and then we will be building a model. We will be building the same model that we built previous time. Right, we will be building the same model that we had seen previously. And we will be actually having a deeper look at it today, and then we will see, if we understand this thing functionally, you will have basic understanding of how to provide solutions to a lot of models, I mean a lot of problems in future and everything, right? So
Anand,
yeah,
will each neuron also, they have different combinations of information of weight, right? Every individual neuron. So
yes,
are they also solving different equations?
they all are having one equation.
So they're all solving the same equation.
They're solving equation is same, but their numbers is different. Now just
Mm.
I'll just
So
show a
for
small
example,
demo.
I1, if I1 was W1 X plus W2Y plus W3Z, right? So I2
Right.
will also be W2X plus W3Y plus W6Z,
I'll,
or will it be a different kind of an equation?
I'll show you. I'll show you. Okay. Let me know when you see my screen. Okay.
Yeah.
Okay. Now, if you see, this is a small demo I have prepared. And this is a real demo. This is no fake demo. All of these are neurons. All of them have same equation. But when you actually start training them, their numbers are different. These are the weights that it is having, right? Now, if I go to any neuron, I click at any neuron as of now, it is having different numbers. Bias is different. Incoming weights are different. Its activation is different. So basically, what might happen that every neuron will learn a different set of weights, although their equation is same, but the weights that they have learned is different. Now, I will be going in it today very deeply. That is, we will use a calculator basically to estimate that what is the individual weight in every neuron, right? We'll just go it on step by step so that all of these things, what I'm trying to tell, these will make sense for you, right? uh, right, Vikram?
Yeah, yes, Anand. Sure.
Now, I know this becomes confusing at certain times. Okay. All right. We start here now. Now, we developed all of these theory from our real life observation, because this is how your brain also works. Your brain learns the same way. Your brain learns pathways. Yeah. Now, although we do not understand complete working of our brain, because our brain is on different level, the intelligence of our brain works on just different level that we are not able to decode completely as of now. The amount of work or amount of electricity one AI model requires, our brain works on a very small fraction of energy on that. And we are very fast with calculations, memory recalling, and all of those functions. Yeah. So, one day our friend, he decides that, and this is how, like I said, it is all about real life, no fancy things, everything.
Hello, hello.
Yeah.
Sorry, I have one question. Sorry, Anand.
Yeah.
So this is Suryakant.
Yeah.
I have a very I was very curious. We are playing a chess, and we are playing with some supercomputers. But
Correct.
the chess is having a limited amount of like the ways or permutations or combinations.
Correct.
That will not be infinite. That will be still a finite number. But still,
Correct.
humans are able to beat the supercomputers.
Right.
Like why it can happen, because computers can recalculate every each and every move and what will be the move afterwards to find that one winning chance.
Okay. So, ideally, what happens that in case if it is neural network, right? Neural network will only learn what you have taught it. I mean, they're not going to self-evolve, or they're not going to self-learn themselves. But having said that, there are AI that can self-evolve, and those AI have been able to beat the best champions in I mean, let's say we introduced a chessboard game to them, and we just did not teach them any rules as of now. But this is very high class AI. I mean, this kind of AI may not be available to everyone, right? And then we exposed it to we let it autoplay for 3-4 days, and then after 4 days it was able to beat the best champions of the world after just learning the chess game for 4 days. Now this is the story of self-evolving AI. This is, however, what happens usually. An AI model learns limited pathways, right? And then we enclose it in a model and put it somewhere on the website or somewhere. Now, what it is going to do is, let's say it comes across any situation on which it was not trained on, so it gets tricked on. Whereas the bigger AI, or that has huge number of neurons, it might self-evolve and it might learn. But yes, I mean, as of now, these kind of AI are limited. I mean, they're not usually available to everyone or on the websites or everywhere. They're usually available. IBM uses it, and big companies like Microsoft, Google, and all of those things. And there are some companies who are into research. They are able to implement it. Like, implementing this kind of AI requires huge amount of research, money, and everything. Not everyone is able to spend that money. Does it answers your question, Surya?
Yes, sir. Thank you.
Yeah. So ideally, small board games, we can create an AI that can excel humans. But yes, it is all about money, and you have to hire experts. Whereas what is happening even now in the market, uh, that people are not. I mean, people, since the time OpenAI and everything came in, now people are thinking that okay, this is the end of AI. even OpenAI can crack limited amount of use cases. Self-evolving AI and all of those things, they did not release, and they will never release it to people. So as a result, what might happen, even now the company has started thinking that why do we need to hire any AI guy for, higher salaries and everything? When OpenAI is doing everything, so why do we need to? So as a result, some of the AI fields might get enclosed to a lot of companies forever because they're not thinking in that direction. And only some of the companies that really have those engineers who are able to do the research and development and do all sort of things, they might only be left with that kind of edge. They can come up with new technologies. I mean, it takes time and money and both of the things. All right. Moving that one of our friend, or let's say someday some foodie friend of ours or someone from our group wanted to say that, I did eat a very delicious dish in Italy, and what I want to do is I want to make it same in, let's say, at my home. I mean, I can't go to Italy, so, but I do not know, I have no idea how to make it. And so what does he do? He says, okay, let me try, so what, even if I do not know how to boil a tea, let me at least try. Let me try. I might just burn it up, right? But at least it's not explosive that I might blow my home. So at least let me start trying. Okay. So this is basically point number one. This is how models start, right? That is, this is initialization of weights, that is at 0 level, where model has not learned anything. So we are at the same stage that model has learned something, right? Or so model has not learned something. I mean, it is at initial stage where you will give some problem to it. So the same goes for your brain. Your brain has not learned something as of now, and it is going to start learning now, right? Then what do you do? Although analogy is very simple, I mean, this is nothing complex. And hence I'm trying to tell you that everything AI has been built by observing all of the things around us only. So I mean, it has to relate to our normal behavior and our brain and everything around us, right? And then our friend starts cooking, he starts adding some spices by reading and everything. And then what is going to happen? Obviously, he will prepare something that nobody can eat, right? Now, and hence the saying also comes, try again. Now, point being that this is where AI has also done first part of learning. That is, what it did was it has an input, right? And then some weights were initialized, and then out of the neural network, the output was produced. Output was very bad. What we did, we compared input and output, right? This is what we do. We compare input and output. Then what he's going to do, maybe he will order that dish again, and he'll see that what was lacking in it and what was lacking in both of things. This delta is called as error. I mean, no rocket science in it. Everyone knows it. So this delta, we call it as an error, and we have just gone through one round of training, right? Now this was a part of training. First effort was part of training. In technical terms, this round is known as epoch. So if you see epoch somewhere, do not get confused. They're just trying to say how many rounds of training has been done. That's it, right? And then what our friend is going to do, our friend is going to say, hey, I'm not quitting, what? Till the time my best dish is not formed, I'm not quitting. I'm going to do it again and again and again, like maybe, right? And then the theory comes in that, what do we do? The theory comes in, first you have to understand the theory, which is quite simple. Here is your neural network. As of now, We will not go deep. I mean, for a few minutes, we will not go deep into this neural network. First, we'll understand few things, that how do we actually train the model, right? We are trying to learn that. So there is an input that we provide. So I have already told you that these deep learning models are big size mapping engines. Yeah, big mapping engines. That is what you're trying to do. You have an input and you have an output, right? And you want your black box to learn whenever this kind of input is given, it should be able to come up with that output. This is what an AI is. They're big size, huge size mapping engines. They will learn. And the other point, you don't have to teach how to learn. They will automatically learn how to learn. You just have to give input and output. And this is the whole art. Basically, you might be coming up sometimes with this theory that this is an art. And why this is an art? This is why it is an art, right? Because in many things you see life is also this way. I mean, everything is an art. That is not approximation. Let's say I say that, okay, you come at 9 a.m. You know what? Or tomorrow the weather is going to be 26 degrees centigrade. No AI or till date has been able to be very accurate with weather also. Right? Let's say we say that tomorrow it is going to be 26 degrees centigrade, it is going to be cloudy, that it is going to be humid, and all those things. It might be close to this, even Google AI or any AI in this world, right? Because we don't have that big AI which can simulate the weather. It is one of the biggest and toughest problem. You can maybe predict a small part of the weather, but whole weather prediction is just impossible as of now. Right? So, right, even if you see that, your weather forecast will say that, now tomorrow it might come close, or it might predict someday, it might predict correct, someday it might not predict correct. Now, if in this case, you see, you're 85% to 90% accuracy if you are able to predict any event. That's a big win for you. You will be able to control a lot of things. You will be able to have edge over a lot of things, and this is the whole game about it. So we want to predict things that many people cannot. And how does it happens? Because we will give it an input, we will give it an output, right? Now, this whole art thing, as you keep on doing it, you will become a fan of it. And sooner or later, you will realize that your whole life is this way. Your whole life, everything is probability. Nothing is approximate that this might happen. And there are so many factors affecting that event in future, or maybe in future, or the past analysis, whatever you take it. Anyway, coming to this is a big mapping engine. You have to manage the input and output. So what we are trying to do is, yeah,
this question. So that means in this model, the black box which is found, we would never know what pathway it is choosing to go from the input to output, right? That's what it can.
So in today's example, I might show you something, but what happens when the model grows big, there are so many pathways that it becomes impossible to track it. Right. There is a startup, I mean, not just one startup. I mean, now even I have also started developing such kind of tools that, I can track that where the learning is happening, where learning is not happening. So now the AI is evolving in this direction. Till now, it has not evolved. The whole point being, yes, we may be able to track it in future. As of now, we are not able to track.
Okay. And the other thing is, in the input layer, there is,
yeah,
is there any restrictions to how many inputs? Can I have 1,000 inputs, for example, for a very complex problem? But
it's your model.
Till
the time you own the model, you can do anything with it. Okay. Only if you use someone else's model, right? You use the model provided by OpenAI, Anthropic, Google Vertex, you will have to follow their rules.
Oh, so that's the thing. Suppose I use OpenAI or maybe Llama, right, from Facebook. Then this model is going to be already pre-trained to a certain extent with a certain number of inputs and outputs.
Correct.
And then I have to work with that only.
Right.
Anand, just one question.
Yeah.
So I'm just trying to understand around this. Like, say, for example, we have two perceptrons, and since if they both are being trained under the same data, so I guess the inputs would be same. And when the inputs are same and the formula also being same, how does the weight get differentiated between these two perceptrons then?
Yeah, it is using a technology called backpropagation, right? And I will just show
So that's what you were
something.
telling, like based on the result, we again train the perceptrons back. So is that what you mean by backpropagation?
Although, yeah, I just gave you a very high level answer, but just wait for 10 minutes
Yeah, sure.
and we will just drop into it.
Yeah, okay.
Right? I will, because these questions have troubled me also when I started back 7-8 years. So then what I started, I am actually using the same thing even in these sessions. I started developing the first neural network from scratch, from zero, from pure, no frameworks, nothing, from just pure numbers and everything. And this is where then I was able to learn. And then for this session also, I have also prepared the same thing. So we'll just get back to it.
Thank you.
Right? So as of now, what we are trying to do, okay, I'll actually start with that theory, right? So what we are trying to do is we have an input layer. And then we have this model, this big model we have. And then we have an output layer. Or output, I can just say output, right? Now, input can be as small as finding square of a number. Let's say we have 2 and it should be 2 square 4 or 3 square 9. Simple. Adding of number. Or it can be as huge as complete sentence. Or it can be as huge, anything complex as image. Or anything complex as video. It can be anything. Because at the end of the day, in computer, everything is basically image is pixels. And again, those pixels are numbers. Video is multiple images combined together, motion picture, right? Video is again a motion picture. That is lot of images, frames per second. I mean, they're still images, but those still images, when they run in specific speed, you feel that those images are live. This is what becomes video. And then basically, then we have sentence. Again, sentence are basically, they can be converted back into numbers. The whole point boils down, everything is number. And then we will see this whole thing in applied AI. This is the whole thing. We will keep on exercising this, that how to convert this data into numbers, and then it goes into this model. As it goes into this model, we get, let's say this is round 1. Now I will start calling it epoch 1, right? Epoch 1, round 1, it says output O1. After output O1, the expected or the real output that we wanted it to have was, let's say, OX, right? Now, OX, how far is OX from O1? Let's say you wanted to have square and you did feed with 2 as input, and it has, instead of 4, it has given 3. So basically now it is still far away from your output. This is what we call as an error. Right? This is what we call an error. Now, the point number 2. How do I, whatever this delta is there, right? How do I teach my model again that, this whole delta needs to be corrected? I mean, correction, yes, practice again. So we go for epoch number 2. I'm going for epoch number 2. I'll get with a different slide because Now, we'll come to the weight section, but first we need to understand the overall process, because if I directly jump to that, we won't enjoy it. And then let's say as of now, there is layer 1, layer 2, and layer 3 layers of perceptrons. These are my perceptrons. 3 layers, each layer having 3, and then finally an output layer. Output layer. Okay, so I got an output of O1 for input I1, and my original output was OX. Error is delta E1, right? Now, here the things get interesting, that we have a process called as backpropagation. This is not a complex process. First and foremost thing, you just have to understand it. Backpropagation is a process. This delta E1, as the name suggests, backpropagation. First, you need to basically update the weights of L3, the recent one. Then you go to L2 to update weights. Actually, first it goes from this layer to this layer to this layer to this layer to the input layer. This was my input layer. If this is my input layer, as the name suggests, this is backpropagation. Internally, how does it happens? Basically, we are using a basically small formula. You know, all this is forming a chain, isn't it? The layers, if I connect these layers L1, L2, L3, L4, and this is output and input, this is forming a chain, right? There's a formula called as chain rule. I will touch base upon this formula, but not in mathematical format, because in visual format, I do not believe in any mathematics that is just written on formulas, because this is what makes mathematics boring. If mathematics is something that changes something in real life and real values around us, then we should be able to visualize it. So as of now, I mean, we have a formula called as chain rule. Using this chain rule, but we don't need to remember this formula anyhow, right? Until and unless you do not want to enter into AI research directly, right? Till then, you just need to know that, okay, we have backpropagation, right? And how does it happen? It happens via chain rule. To get more understanding, right, we will get more into it. Now, again, coming to the aim of the course is applied AI. It is not research AI. We're not going for a PhD or anything. Like, we won't be doing that. What we want is, we directly want to use AI to build applications, and hence applied AI. So very carefully, what I have done is, I have whatever the important details we need, we'll only touch base those. All the unnecessary mathematics that is required for researcher, not for us, right? And how many of people are doing research as of now? It's 0.01%, right? There are very few people who are genuinely doing any research. There are very low research opportunities. Everything around the AI buzz is this applied AI, right? And even if you go these three definitions, backpropagation, and then there is 1 to 2 more, you know, I'll explain it to you. Just you have to take care you don't forget it after 2 weeks, right? Even these specific definitions, even 3, 4, 5 years of people having AI experience, even they are not clear with how it is actually happening. So the whole point, my being that we have to concentrate on the right details for developing the application, right? It is very simple as that. Like, when, let's say, we are using any framework for developing applications, so we need to understand that framework, rather than we going into how does it runs on GPU, what is its flops per second, how does it runs on CPU, right? These all and what is the equation for running it on GPU and CPU. Yes, if I want to be like, if I want to you know, develop machines for specific those applications or anything like that, I need all of those details, right? So, like this is my area of research. I mean, I love doing this kind of research. I love writing research papers and everything. So, I mean, this is my area of research. But unfortunately, you know what is happening in India? There are hardly 2 or 3 companies that who invite research, and that too, those positions are limited to 5 to 6 itself. I mean, this is this low. While applied AI, they have you see all of the AI engineers vacancy everywhere, you know, or AI based project management. It doesn't has to be you have to go and develop it. You can be you can just give the solutioning, consulting, or you can be a product manager, anything. I mean, even for being a product manager, you have to know the functional thing, right? Now coming back to it, I hope this theory I have not made it complex till date. Team, right? The theory is very simple, that it forms like a chain. It forms a chain, right? Now, if you visualize, it is actually a chain, you know. And then what happens? We have this delta even. Now it's time to teach my each and every weight. It happens via a process called as backpropagation. Backpropagation is like that one friend in your group, right, whom you tell anything, and he is responsible for spreading it throughout the city, right? We all have that one kind of friend in our group, right? So these are all our weights. And what is its responsibility? Its responsibility is basically to go to each and every neuron, or to at least to get touch base with each and every neuron, right? Backpropagation, right? Its responsibility is basically to calculate, right, how much each and every neuron's weight, or how much each and every layer's neurons weight have to be updated, right? So first it will calculate how much for every neuron. How does it calculate? Using a method called as chain rule. Chain rule is a concept of calculus, but nothing complex. I mean, I have a small visualization of it, so don't worry. You will not even know that I explained to you chain rule. I'll tell you after that this was chain rule, right? So don't be afraid of it. Now it's a part of calculus, right? Okay, but anyway, again, calculus is again related to our real life. So I mean, it is basically what I very much feel. I mean, just sharing something out of the context. I feel if someone is making maths boring, it's a crime, because you know, maths is something that relates to your real life, and the subject has been taught in such a wrong way, with no visualizations, nothing, just formula. So I mean, hence people feel, oh, this is so complex. And so like I said, this chain rule, if I just write you an equation of this chain rule, that dy by dx into dx by and so, if I write this equation, right, and limit is x tends to 0, and you will just feel that what the hell is this math. If I just make you visualize this, okay, this is how it works, you'll feel, oh, this is it was, right? So anyhow, so how does it work? So okay, backpropagation is that friend who has special capability of giving information to your whole society, right? You tell them that, you know what, I'm going to get a new car, and then in just overnight he has that special capability of chain rule. You know, even these people have those chains, WhatsApp chains. He will tell to someone, and x1 person, and then x1 is going to tell to x2, x2 is going to tell to x3. They're also following chain rule. And then the next morning you go for a walk, and everyone is like, so when are you going to get your new car? So where are the sweets of the new car, right? Okay, so this is how back propagation is, and then back propagation has done its job. That's it, done, right? Next is this. There is another process. They have named it as gradient descent. They named it as gradient descent. What is gradient? First and foremost thing, what is gradient? Back propagation did go to each and every neuron that how much weight has to be updated, right? The sum of all of that change is gradient. The sum of all of that change is gradient. Sorry. The sum of all of that is a gradient, right? And now the process of updating those gradient is called as gradient descent, right? Reiterating the same things again. I just want you to tell the terminology, right? And you should just be remembering this terminology. First is back propagation. What does back propagation do? The role of back propagation is to go to every neuron and calculate how much weight has to be, how much weight and bias both. When I say weights, I mean it's weights and biases needs to be updated, right? It says how much weights and biases needs to be updated. Then the collection of all of those delta change that needs to be done is called as gradient. Gradient is the total change that we need to do to all neurons combined. And then gradient descent. Descent means going down, right? Why it is descent, I'll just let you know. But just remember, gradient descent is the process of updating those weights. Updating those weights. This is the whole process. Now, without doing any further delay, I'll take you to the demo so that we understand it. And the same thing was happening here also, you know, the same analogy, the whole thing repeating again and again. And then one day, the dish that our friend wanted to prepare has been prepared. It's there now. Now, let's go to visualization. There is no learning without any visualization. If I just explain all of this thing just via I have two visualizations. All right. So here we have, we will reset. Now, basically, this is my neuron, right? What it is trying to do here, if you see, it is actually trying to right. What it is trying to do here, it is actually trying to, you know, train the neural network for multiplication. I mean, as simple as that. Although just a waste of time, because For multiplication, you can just put cross. But the whole point being, it is like a printf statement, a printf statement for neural networks. Assume it like that. So what is my sample? This is my sample: 8 into 3, 24, 0 into 9, 10, 4 into 1, 4, 6 into 0, 0, 7 into 7, 49. This is my training set, right? Two inputs. Here I have two inputs, right? This is input number 1. This is input 1. And this is input number 2. Right? And then I have a mid layer. As of now, everything is 0, 0, 0, 0, 0, 0. Output layer is also 0. I have taken some random weights because my weights cannot be 0, because if everything will be 0, the whole neural network is going to be 0. Right? So I have to start with some random weights. I have taken all random weights. Right? There are ways to initialize these weights also via various strategies, via various formulas. Right? We will discuss them later on. Right? So L1, weights initialization, there are 3-4 very famous techniques, but as of now, no point of making it very complex. These are the random weights, and these are the neurons. All of this neuron have the same formula. Okay, let me see. Okay, see, as soon as I click this, I'm able to see here the neuron detail. As of now, just, the bias is having some random thing. Activation, input, and everything is 0. Even this. Now, I can either feed it with 1 or 3, 1, 3, but what I have done, so that everything comes down to smaller number. A simple formula for data learning is that you minimize the scale. That is, let's say you might have some data from 0 to 1000 or 0 to 10,000 or 0 to 1 lakh, right? What might happen, since this whole weights are acting on multiplication, so sometimes these weights and biases might become so huge that they might just become out of control. We have specific terms like vanishing and like diminishing gradient and all of those things. We'll talk about it later. But the whole point being, what I have done, I'll just reset training network and I'll go for start next training step. First input has flown 0, 2. 2 has basically been divided by 9, because all my inputs are between 0 to 9. You could have fed the exact 2 also, but the whole point being, the numbers would have been so huge that they would have just gone wide here. So I wanted my numbers to be between 0 and 1. The whole universe, you can scale down between 0 and 1, right? So scaling down is the whole purpose here. Nothing complex here. So do not be confused. 2 inputs here. After 2 inputs, what happened? It went for an input and it produced an output, right? Now show back propagation. Okay, it has calculated this back propagation. Now, if you see, initially weight initialization was different for each and every neuron. Here was the answer to, I guess, 2 people asked today, that if weights are same, formula is same for all of the neurons, then what is different? Weights are different, biases are different. And this is the whole game, that weights and biases are different, so if you see, even these weights are getting different. As a result, these neurons have learned it differently. Update the weights. Let's go for updating the weights. Okay, the weights have been updated, right? Next training step, 8, 0, 8 and 0, right? Show back propagation. Okay, again back propagation. So it has basically here back propagation has happened. Update the weights, right? I'll just start with auto training, because obviously it is going to take huge amount of time. We keep on doing this, we keep on doing this. It's dot auto-train. And this is basically the loss. The loss is decreasing, gradually it is decreasing, gradually it is decreasing, gradually. What is the best way? The loss should be minimal as much as it is decreasing, it is decreasing, it is decreasing. Now it has become constant. There is some problem we will have to solve. The loss is not moving anymore. That is, my model is not learning anymore. It has learned up to a certain extent. Now I can keep on training, but it is not learning anymore. It may be due to various factors. I'll just stop here. It may be due to various factors, right? Or these weights might have converged, or the gradient that is getting calculated may not be too much. Actually, what I see, the gradient has, this is too small. The gradient has become too small, 0.0060, 0.0060, 0.0040, right? My gradient might have become too small, and hence now it is not learning anymore, right? So these kind of issues can arise. This was just for demonstration, right? Now, this, it will produce output even now also, but not the correct output. Now I'll go to switch to inference mode. 0 and let's say 9. As of now, it gives 13, which is completely wrong, right? 2 and 4, it will give some output based on learning. 3, this one is 2 and 4, it should be 8. Basically, it says 2 and 8, it is 18. This time it was quite close. Now, basically, along with it, what I'm also doing is, because I wanted to show you those learning paths, you see 2, 2, the whole point being the visualization. These two have worked this time. 2, 7, something else lit up this time. 2, 2, it is something else working this time. 6, 3, it is different set of neurons working this time. Or maybe they might not have learned this network, this path at all. So the whole point being, what I'm trying to tell you is, what is happening here is, again, going back to the same slide, right? What happened here was, or I'll come here, right? What happened here was, there was an input and input layer, output layer, so mid layer, and output layer. This was very small neuron. Ideally, you will, even for solving this problem also, you will at least need, you will have to increase the number of neurons, and then increase the number of, I mean, I just took very small sample also. My sample size was also very too small. My sample size was also too small. And hence, after a certain time, my gradients stopped affecting my weights, So what happened was, process find how much each weight in each layer has been updated, right? This was getting calculated. Then we did calculate gradient also, right? That it was showing the symbol here, right? While we were updating. And then when I was clicking update weights, gradient descent was happening. It was updating my weights. Now I am open to more questions, because I'll have to see how much understanding have you developed about this thing. More questions and more understanding. Hi team. Any questions?
Anand, so is it, will the learning improve if we, let's say, add additional layers? Like we saw that at one point it was not learning because maybe the weight started converging or became very small.
Right.
So at that point, if we add two more layers, then will that make any difference?
Yes, that is one of the points, right, where it starts making the difference, right? Now, here comes two important points. I have jotted down them in slide also. Hold on. What is model parameter and what is hyperparameter, right? So model parameters are weights and biases. The weights and biases are called model parameters. When you actually call this is 30 billion parameter model or 40 billion parameter model, this is what you mean. Then there is another thing called as hyperparameter. What does it mean? Hyperparameter means number of hidden layers, number of neurons per layer, how much data are you feeding in, number of epochs, that is number of rounds, right? Again, don't be confused with this. Activate, what kind of activation function are you using? Don't be confused with this specific word. This is just one. Again, activation functions are just step functions, on or off, right? Or like, should this neuron fire or not? Now, coming back to even that original question, that is it impossible to know what is going in the model? It is dead complex. Now, in this model, I mean, this was small 7-8 neurons model. We were able to see what is going inside the model. But you know, even millions, 10 millions, 20 millions, 30 millions, it becomes very complex to know. But yes, I mean, this field has also started to evolve. And I will try to show maximum by developing the tools, what is going in the model, you know, so that, you know, we can dig deep into the model as much as possible. I mean, we won't be able to know everything, but at least a lot of things we will be able to know. So hence here the question that was raised in the starting, that what are model parameters and hyperparameters? Obviously, this is something you control, right? You control. And training a model is all about hyperparameter optimization.
And then
When we
this
say we are training the model, we are optimizing the hyperparameter.
Anand?
Is it clear?
Yeah, Anand,
Hello, team.
Anand, I have one question.
Yeah.
This backpropagation happens during training or during testing?
During training only.
Training only. Okay. So just to reiterate my understanding. So in the training, the first step is like in this example which you showed just before this. So we randomly initialize these weights with some random numbers, and then we send it in the first round of epoch. So it calculates something, and then it compares with the desired result. And whatever the difference, it tries to adjust the weights for the difference, so that to get the exact result, it keeps adjusting the weights. So again, in second epoch, it runs, and still if there is a difference, it keeps adjusting the weights using backpropagation.
Yes. Yes.
Till it reaches the loss function as 0.
Minimal, right?
Okay. Okay. Yeah.
Yes, this is the whole process.
Yeah. Okay.
And hence, like, I have been calling this deep learning by various names also, like weight management. I mean, this was just for our understanding, you know, easier terms, like how easy it is to update weights. You know, the whole science is about the proper weights so that input and output match.
Okay. So the entire complexity is inside the backpropagation or the chain rule, which you said, right?
And the arrangement of neurons.
So all that comes with understanding of how to arrange, that also comes with trial and error, or is there a definite set of patterns for each kind of problem?
We know few architectures,
Okay.
but yes, for cracking a new problem at all, like let's say you want to develop AI for something, for any problem that doesn't exist very commonly, right? Then we will have to hit and try. There are tools also wherein we can do all of this hit and trial.
Okay.
Any more questions, team? None? I was expecting a lot of questions from this section. Okay, anyways, we'll reiterate over the same thing and then we'll continue. We'll have to build a model also today. So basically, what we want to do is we'll be training a model.
Anand, I have one question.
Yeah.
Sorry. The question is like, how can we decide the importance of, let's say, we are giving X1, X2. These are the features, input features for us. So which of that feature is important for making a decision? So how can we derive that importance of a feature?
There is certain amount of study that like how to find first correlation between the features. We have one case study today that is practical also, wherein we will be studying that which features we should be feeding in, which features we should be not. Now, ideally, the more feature engineering that we do, the model will have to train less. Our deep learning is such a way that even if you are able to feed any feature that is not making a lot of sense, after n amount of training, it will automatically isolate that. Any rule that is not getting established, it will automatically isolate. But best practice is, first we will have to do the analysis of the features, and then only we'll have to see that which features should be going into the model. So feature engineering still is relevant. It will reduce the work of model. It will save money, because at CPU time or GPU time means money. You know, when you're burning GPU, we are wasting money.
Okay, so basically, if we want to derive a relationship between an output and the input, so which input parameter played an important role in making a decision? So is there a way, like a gradient of that error, or some way through which we can?
We have to hit and try. Basically, we'll have to give some parameters. We'll have to reduce that parameter in another input. So there is complete framework for doing that. Whatever the ML flow and all of those things, you know, experimentation with the same data, you end up doing at least 40 to 50 experiments. And after doing all of those experiments, you finally have that, okay, this, by changing this is what changed in result, and you keep on logging them. Like in ML flow basically does that. There are other tools also. ML flow is a free tool where you can track all of your experiments. And then you keep on optimizing that. You keep on optimizing. And then at one point you realize that, okay, this is the most optimized feature set, and this is the most optimized like weight combination hyperparameter sets that I should be using. And then we export that and then we host it somewhere for customer to use. So it is, like I said in the starting, it is more of an art. However, in our case, let's say if we are going for AI engineering, in most of the cases, we will not be building the AI models from scratch. Because again, if it is simple text classification or simple image classification, then it is a different story, and already very good architectures are present for that also. However, for any complex problem, we will be mostly working around, LLMs, AI agents, and RAG architectures. These are the new terminologies that have popped up. Again, RAG is also something that is not perfect. I mean, it is not, it hardly has 94 to 95% accuracy, right? But again, these all use cases have popped up recently. And most of the time, we end up doing those jobs only in AI, at least in past 1.5 years. But all of this knowledge will definitely help. I mean, without this, we will not be able to do anything. Even small change, if we have to do in the model, we will not be able to do.
I have two more questions. First question is like, this was a very simple model. So like, can't we use, like should we decide to use a deep learning model versus our classical learning model?
Yeah.
Classical supervised.
Yeah, classical problem solving or rule based. Basically, either you develop rules or see, there is one very important point that we need to consider, that what is the scope of our problem. Let's say my scope of problem is limited. If it is limited, my scope, let's say here I decide the scope. If let's say my scope of the problem, DL, where it will be useful. Let's say you have made some model, and this today I'll take an example, let's say, of plant disease classification. Let's say we are developing some application for farmers, and what its job is that it takes a photograph and it automatically tells that what disease it is, and it also tells the area, that these all areas seem to be infected. Right now, basically, these kind of problems developing with rules is nightmare. I mean, it is just impossible to put rules that is going to on top of that. I mean, this problem is like, okay, we cannot, but let's say we want to develop any simpler problem. Now, any problem where we do not want to change the code, we just want it to expand by more training and data. Just by more training and data, we just get the model and we replace the previous model, and new use cases start getting popped up. This is the place usually we start using deep learning. Let's say you want to do some simple forecasting of your inventory. Now, this is, you do not need to use deep learning for that, right? Simple inventory that, okay, this is my inventory and this is when it should be filled up. And let's say next month, if based on my past 3 years experience or previous year inventory data, this is what it is, right? So you do not need huge deep learning models for that. But yeah, obviously the kind of problems that we are seeing nowadays, let's say this disease detection, or a news came into picture that AI related hospital has been opened up in China. Again, it is screening of diseases. Then basically you have to submit your reports reading, or one of the, like Vikram asked in the chat, that how AI is used for defense systems. Now, basically the Iron Dome technology, let's say there is any missile that is going in the sky. Now, AI using vision models is able to track that down. It tracks it down and it hits it with a different speed. I mean, these kind of things are impossible to come up with a rule-based system. Are these things perfect? No, even Iron Dome is not 100% accurate, but yes, it is like 92, 93% accurate. And that itself solves huge problem. Even this plant disease detection, it is not going to be 100% accurate, but even 93, 95% accuracy, it is huge. Even if 5% it is leaving out, I mean, that's okay. But yeah, 93 to 95% also, it requires a lot of hard work. I mean, it's not that easy that we will have to work a lot on the data, then on the model and everything. I hope it answers your question.
Yeah. Yes. Okay.
So,
My
Anand,
last question is like,
Yeah.
yeah. So my last question is like, there are certain times like your each feature vector, like what you are given x1, x2, it will
Right.
have some next rows. So like we are talking about the training examples which are not dependent on your future, like my past rows or my future rows. Like I'm talking about
You tell
only
any
we are
one
talking
example.
about, let's say we are talking about a text like we are sentiment classification we are doing. So
Yeah.
that one when we are saying a text, it is comprised of a sentence, and each sentence is a word.
Correct.
Okay. So we have to give entire sentence as an input to a model rather than just each word as an input.
Correct.
So in that way, our each word is linked in a sentence is dependent on each other. It has some
Correct.
context or dependency on one or each other. So in that way, this 1 point model will not work, right?
No,
We have
these are
to
just for
use a different.
demonstration, right? So that
Okay.
we are able to understand what's going inside that black box. As soon as we start with any text processing or anything, it is going to be big models. We will see one small example today of complex image classification. So yeah, in that case, those models are going to be big. I was just actually trying to train one small model before the class. It took me approx 40 minutes on CPU. And then also it broke down because something changed in my system, so it broke down due to that. Now I'll be giving you that model also. I mean, small things. So like I said, now
Okay.
it's about arrangement of neurons. If it is image, then obviously image is basically either 2D image if it is black and white, right? Or 3D image. 3D image because image with colors, right? So there is one more dimension added to it, right? We added this one, right? So now my input model has to change in that way, that input neurons have to change in that way so that it can accommodate my input. Being applied engineer, what we have to do is we have to first actually see, we will not be looking too much into, because like I said, I mean, this is a deep science, and you have to go in a lot of hit and trial and a lot of other things. Being an applied AI, first we will see how we can break down various inputs and we can feed it into neural network. Obviously, we'll see how to build models, simple models. We'll see. Even we'll be building one small LLM also. But like, will it be production grade LLM? No way. I mean, we don't have that budget of the course to train a LLM from scratch, right? I have that. I have trained that model for. I mean, I've written in 14th chapter of my book also. Training LLMs from scratch using PyTorch. It is a book by me. Right? So that also has 14th chapter about that, and that book is specifically about building models. However, in applied AI, what we are talking more about is we will be building, we will be having more like our applications on that, how to break down the data and feed it into the model, optimizing the model, and then building applications around those models. Now, it is not just models. Like around LLMs, we have agents, right? We have RAGs, retrieval augment generation, right? Then we have fine-tuning LLM. In just fine-tuning LLM, there are 2 to 3 ways, right? There is LoRa, there is QLoRa, all of those things. LoRa, QLoRa, RLHF. What is RLHF? So RLHF is again updating, going and updating weights in real time. So I mean, if you do not understand this basics here, then obviously we might struggle in this module 2 and module 3. So yes, we will be going through building these models, but not to a very in-depth extent.
Okay. What is the activation function used here for that example, previous example? It was simple.
It was ReLU.
Linear. ReLU. Okay.
Let's write it here also. I guess I mentioned it somewhere. Yeah, activation example ReLU, right?
Understood. Thank you.
Right. Vikram, you had any question?
Anand?
Okay.
Anand,
Yeah.
in this course, will we be seeing all this fine tuning and all later?
Pardon? Sorry, can you repeat the question?
Yeah. What I was asking is, will this course in later weeks will we be looking at fine tuning also, like how to do fine tuning with LoRa? All
Yes.
that?
Yes. We'll be seeing that.
Oh.
That isn't really a lot of complex thing. Again, that is a lot about using Hugging Face, and then you basically Hugging Face has provided library. However, the complex thing again becomes there is understanding the architecture. We have to understand the architecture. How do we need to update it? Then again, updating the models, even how to host them online. So I did not mention it, but we'll be covering about hosting the models also, because obviously with applied AI that has to come into picture.
Okay, Anand, I have one use case. Is it okay if I discuss this now or maybe later in the class?
Yeah, you can even write it in the sheet. Okay, maybe you joined later.
Yeah.
So I have shared one sheet wherein everyone can, share whatever you want to build using AI.
Okay.
Right. So yeah.
Sure, I'll update.
Sure. All right. Now going forward, see. Obviously, we're not going to build some so small models, right? This was for demonstration. And this was basically to understand how all of these things are working. In real life, we will have bigger problems. So gradually and slowly, the whole point being gradually and slowly, we will have to move towards complex models. And along with, the right visualizations. So in last class, that is on Sunday that we held, so I did show in the end of the session, I did come up with a small example. It was based on AutoKeras. Right? Now, what is AutoKeras? Basically, it is a part of AutoML. What is AutoML? AutoML is basically where we just manage input and output only. This is for beginners only, right? Although you can use it in production also, very good tool for building small models like this for input and output, right? We have input and output. Now, all of the internal part of hyperparameter optimization is taken care by the framework here that is called as AutoKeras. There are other also available. There are a lot of AutoML frameworks available, including on the cloud. Right? You can use SageMaker. SageMaker has its own AutoML framework. Google comes up with Vertex AI. Right? On Azure, we'll have to find out. I do not know the exact name. There are a lot of other frameworks like we have AutoKeras. Right? We have H2O. These are some of the frameworks. What does it do? Basically, you provide it with an input, you provide it with an output, and you tell it, you know what, You keep on experimenting. Experiment with various layers. Experiment with various parameters, layers, parameters, and you keep on doing that until and unless you don't find the best optimized solution. So this is what is AutoML. Ideally, all of this thing, when we are doing, we do it manually because this is, I mean, active area of research. But yes, I mean, this is what the complete hit and trial, what we are doing here. We're giving it to AutoKeras. We are telling it that, you know what, you do it. And once you are done, you just give me the input and output. So like I was just talking in the previous slide also, that my whole concentration first, at least, is going to be understanding my input data, how I can actually feed my input data into my neural networks or any framework, basically, right? How am I going to do that? And then basically my output data. Now, so if you see now in the chat, I have shared one link with you all, with all of you guys. Right. So there was a chat in the link that I did share with you. I guess this is the one, and it says exercise notebook 2, creating housing prediction models using AutoML. Right. We'll have to understand a lot of things here, but you know, this is your exercise where each and every cell has been crafted in a way that you can just go ahead, read it. In this exercise, I have left some of the filling the blanks so that you go and write them. Don't try to like get it from internet. I mean, these are very simple ones, obviously anyone can do, right? So just the whole point being, you go and interact and write some cells and then you run it on your own. But first we will be running this whole exercise. Now I will be giving such kind of exercises more. So make sure you do all of these exercises, and then we can make a small, kind of checklist where you can submit me these, so that, I mean, the whole process being that, yes, we are completing these exercises, because again, coming to the point that if you just sit and watch, you will forget it very easy. I mean, this is a practical course, so we'll have to do it practically. Now, each and everything will be covered very precisely. Do not worry about it. Now, AutoKeras, we'll talk about the AutoKeras first. AutoKeras is, you know, one of the simplest libraries that we can use. Here, if you see, this is the smallest AI model to run. What this model is doing, here I did run this model. This model is basically, I did import AutoKeras first and foremost thing, and then I imported sklearn.datasets. Now, in the first session itself, we did some vibe coding. We generated our own code, you know, using sklearn and everything, and sklearn datasets. We tried with a decision tree, trying to differentiate. Now here, what we are trying to do, first we are just using AutoKeras. So AutoKeras is as simple as that: import AutoKeras as AK, and then I'm trying to load my data from sklearn. Now, as of now, we are not writing this code. I'm just trying to demonstrate you that how easy this AutoKeras is. I have a complete exercise to go through. That is, we'll go through this whole exercise step by step, and I'll recreate this whole exercise before you. This is your exercise, you will have to do it. I will be recreating line by line here. Right? So basically what I'm trying to first explain you that what AutoKeras is. AutoKeras is simply we have to manage input and output. Right? It simply says first we have to import this model, and second it says just load these models. That's it. Dataset dot load data. Second, I have to manage the pixel of these models, but I will come back to it because these are the things that we have to learn. I will have to arrange specific sessions on understanding these things because we will have to understand how to move these variables to GPU, to CPU, etc. Right? So we'll have to understand these things. As of now, what is being done here by mine, what I'm trying first, I'm just downloading these data, and then I'm changing my shape of each and every, this is my image. I'm changing the shape of each and every image to 8 by 8 because initially everything is a pixel. So this is one dimensional. So this one says one dimensional and 8 by 8, right? That is 64-bit images are being converted to 8 by 8. If you find it complex, leave it because I will be revisiting this whole thing in very depth. The whole aim of, as of now, showing to you is that how easy it is to get started with the model. I'll have to reinstall, I guess, AutoKeras. In Colab, we have to reinstall. I've given the exact versions. I tested them and I gave you the exact versions. Right? So go ahead and install them. Now, why these exact versions? Because AutoKeras works on some predefined libraries. Ideally, all of the basic frameworks that will be working in future like PyTorch and everything, they run everywhere usually. But yes, this AutoKeras is specific with these libraries itself. So I just pinpointed these exact ones. You just have to go and run it, and your environment is going to be ready.
Yeah. What is the meaning of this question?
Yeah, Surya, anything?
Yeah. What is the meaning of the libraries that you are installing? Like, can you just throw some light on that? Like, we are having Keras underscore NLP.
Just give me a few minutes. I'll be discussing this whole notebook step by step. Right? The whole point being, I just want to show how to start training. That's it. And then we'll have to restart it. Any new installation that you do, we usually restart the session so that new libraries get reloaded. AutoKeras still not detected. Okay, I still have to install, I guess, AutoKeras. Anyways, we'll start it. The AutoKeras usually gives these kind of issues, but I'll fix it. Don't worry. In the meanwhile, I'll keep on fixing this. So this is specific. I mean, AutoKeras is basically some older library, but for
I
understanding,
think we need to install the pandas
the
to a
Pandas
specific
is
version.
already there. Pandas is already there. So basically, this is a clash between TensorFlow and various other libraries given by AutoKeras. AutoKeras forces some libraries, and it like clashes with the existing libraries of Google Colab. I fixed it twice since morning, but then again, I thought that I don't have to do it in the live classroom, but that's okay. We'll take care of it. No worries. The whole point being that what I'm trying to do here is that what I was trying to show you that here I have loaded my data sets. Here I'm taking a ready to use data set, that is a digits data set, a very lightweight data set. You know, if you see, this is for 7. Now, if this is another number, this is simple pixels of very poor quality, 0, right? Again, 0. I guess this is 2. So basically, this is just for understanding. Obviously, in real life, in fact, this was the first problem in 1980s that ML cracked, right? That is identifying the digits automatically. It may be handwritten or any, and using the same basics today, we are able to crack down understanding of texts or OCR or anything, based on huge amount of training and etc. So what we did here, basically, we just did load the data. Now, AutoML, what it is saying that you simply do, you make the object of classifier and you run it. These 2 lines are just required for starting a training. In fact, here I have specified some parameters also. Here you don't even need those parameters. You do not need these parameters. You can simply go with default parameters, but it is going to take at least 2-3 hours for training. And then finally, you make an object, you start the training, and you can test your model. As simple as that. You train the model and you give it. Now, basically, what it is going to do inside, it is going to, let's say here, what I have given max trails is equal to 2 trials. Sorry, max trials is equal to 2. This is the number of model architectures it will automatically go and test. You can keep it 10, 20, right, 15, and there are more parameters that we can feed into this function. So first example, we will not go into building our own model, because for that we will need more knowledge of PyTorch. Now I'll have to go into more depth of tensors and everything that we will have. Maybe we'll start tomorrow. But as of now, my whole point was that everyone should be able to first start building the models. They can understand what model looks like, and at least they can start classifying these images and small things. So this gives us a small confidence and boost that what we can do, and then we can start digging into basically customization of models, building custom models using PyTorch, etc. Now here, first we will have to fix this. You'll have to give me 5 minutes in the time I fix this. In the meanwhile, if you have any issues or anything, any doubts, you can kindly ask me. also question is
Anand, is
yeah.
it possible to use something other than Google Colab? Because for me, it just does not work. I'm not able to, my current Gmail ID has completely exhausted the space and I'm not able to create any new email ID as well on Gmail because it says my phone number is used too many times. So,
Can you create a new Gmail ID?
no, that's one thing. It's not allowing me because nowadays to create a new Gmail ID, it's you have to connect your mobile also to that using a QR code. And
Okay.
there it gives an error message saying that this phone number has been used too many times. I don't know what that means. So it's saying please try with a different mobile number.
Okay, I will give you, you can do these simple things on Kaggle also.
Kaggle.
So, Kaggle, yes. I'll help you in creating an account on Kaggle, and then maybe you can practice on it.
Okay.
Right. Yeah. And I'll keep on working on it in one notebook. In the meanwhile, what I can do is I can start with at least half of the program. And when I am done, I will switch here. That way we don't waste our time. Right. So here the first point being that this we had discussed previously also, and this time it ran. AutoKeras is running. Let me check if I'll for the demonstration I'll start training now, because this training takes a lot amount of time. Okay. See, what it has started doing is it started running trial 1. My max trials are just 2. Although my max trials are just 2, by default, if you go, I guess the max trial number is, I guess, 100 or something, which is going to take you n number of hours. And so even one epoch is going to take a lot of amount of time. It is going to test 2 best optimal architectures, and then based on that it will automatically decide that which one to choose. It will automatically give you that this is the best one and this one you should choose and go ahead for testing the model and all of those things. But anyways, I will stop this training here. My whole point was to demonstrate that it's dead easy with lot of tools to get started with it. However, starting from our first day theory, that the whole point being we first select a problem and then we see all of the relevant theory around it, and then we create a solution around it. Right. I'll just stop this training for a while. And with AutoKeras, initially when you run this program, you might face similar kind of problems, right? AutoKeras version is 2. Okay. Sometimes, not usually, but some libraries are very sticky around what versions they should be running around and all of those things. I've just noted down what works here. When I give you this notebook, this easiness might come with small amount of struggle, but what I will make sure, I will rerun this notebook so that you do not have to go through this struggle. I will make sure that it installs smoothly in one command itself. You don't have to struggle, and you can just go through the whole notebook step by step. But yes, you'll have to go through the notebook, and then I'll give you a checklist, basically, wherein you have to just write down, okay, you have done this notebook, so that there will be few practical sessions that we'll be going through one by one. Anyways, okay, we have this now, hopefully up and running. Now, starting with this thing. What we are trying to do here, first and foremost thing, I'm trying to load the data set, right? There are sklearn is a library that provides me a lot of functions, but mostly I will use sklearn for two things, right? What are those two things? First thing being that I'm going to use for loading the data sets, right? So it has a function wherein it provides certain ready to use data sets that I'll use initially, but then later on, I mean, I'll have to load my own data sets from CSV file, from XML, or from various kinds of data source I can load my data. Second, I will be using for splitting my data, splitting the data. What is the point of splitting data? The point of splitting data is, let's say I have this data and I have to split it into 20 and 80. That is 80% of the data I will use for training. And once my model is trained, I will check on untrained data how it has performed. Right? Ideally, here we are doing it automatically using 80-20 rule. In real life, just bifurcating what data you need to test on and what data you need to basically train on is a very time consuming task. It may take from weeks to few weeks because the whole game is about data here. How crucially, so you'll have to treat AI model like a child, and you have to carefully see the data, that what data you need to keep and what data you need to remove. Only then you're going to get the optimal outputs. And third is for confusion matrix. What is this new thing? Well, confusion matrix should not confuse you, right? We will have a look at it. What is this confusion matrix? Right. Confusion matrix is usually used for calculating accuracy, false positive and false negative. What is this false positive and false negative? Don't worry. These are basically terminologies that we'll see. Anyways, going to our exercise. Okay, I was writing something and sorry, I missed it, I guess. Right. So what I was telling you that we will be using sklearn library. I can type it here itself. sklearn library. This sklearn library will be used for basically loading the data sets, right? And apart from loading data sets, we will be using for splitting our data, and then thirdly, we will be using for one more purpose, that is confusion matrix. That's it. As of now, in PyTorch or in model building, everywhere for these basic things, it will be used. Or it also provides some basic functionalities. When we'll go to some advanced topics, we'll start doing that. Also, one important point being that if you do not practice, it will be very hard for you to follow some advanced topics. So it's not just about attending theories. We'll have to practice. You will stumble somewhere. You'll come up with a problem and your problem gets solved. Thus, you start doing it, right? So, okay. Now here, this function, what it is doing, it is used for fetching the California housing data set. What is California housing data set? We see here, this is our data set. We'll soon come to it. But what is the meaning of as frame is equal to true? Although in the exercise, if you go ahead and see, I have written each and everything very carefully, right? What is the meaning of as frame is equal to true? Argument tells scikit-learn to return the data as data frame, which is like a structured table similar to Excel data sheet. That is just for visualizing purpose, right? Guys, just give me 1 second. Okay, I'm back. So basically for visualizing the data set, we use Pandas DataFrame. Now, once we go towards our PyTorch, right? In that case, what we start doing is I will be visualizing, visually showing you all of the data. Even here we are visually seeing, but how do we perform on the Pandas and NumPy? We'll be holding that small session, maybe of 1 hour, only the required knowledge which we need. So we'll be having that. Now, going towards visualizing the frame. Now, frame is something that actually returns me the data in data frame, right? Simple parameter we have. And here I am able to see my data. I try to. Okay, it was taking some amount of time. I wanted to show in the tabular data format. What are my input parameters, or what do I want to actually? So this is median income. So basically they have averaged out, and basically then median income, house age, average rooms, average bedrooms, population, average occupation, latitude, longitude, and the house value. The idea is that we want to find out that what is the value of my house. Now this problem we are trying to solve using our neural networks as of now, right? So first and foremost thing, I guess someone asked me in the same session that how can we actually find out relationships between these data. So basically what we need to do here is in order to find out any kind of relationship, we will have to follow certain kind of procedures. We'll see common practices of relationship finding, because obviously relationship finding is a huge statistical ongoing research field. But yes, some of the common things we will study here, and some things you will develop with practice. This is nothing, like I told you, that this is an art field. The same chart, when I see it, I may be able to come up with different set of information, whereas the same chart, when shown to someone else, they may come up with different set of information. This is so subjective. The chart seeing and the data observation is very subjective, and it needs a specific amount of practice. You will have to practice. When you go on practice, when you keep on practicing, obviously, then slowly and steadily, I'll in forthcoming sessions, I'll show you some charts. Both of these charts, you will see that there is no difference between these charts. But then I can find, like I have been also be practicing. Since this is my field, I have been practicing this. And then says this charting and every technique is so widely used in weather forecasting, in analysis of lot of things, dashboarding, forecasting with inventory, forecasting churn prediction. So these small patterns are hidden inside the charts. I will have a look at this case study. That these are very simple things that we have, and we will try to find out that what all things are present here. Now, coming to the point that exploring the relationship. So first, what we are trying to do, we will plot simple scatter plot, right? Since we'll try to plot two kinds. Now, what I have already done, I have already made small function, helper function for you, which we can use always in the course. So in order to plot a scatter chart, all you need to do is just provide with a data frame here, right? And X column, Y column, title, X label, Y label, right? And what is the transparency density you need to maintain, and what is the color that you want, right? This is it, right? So and these functions are present in the top of this. So I have taken care of, it's here, I guess. Worksheet and installing, right here it is, helper functions, right? these are the helper functions. These are already present here, right? Now, these are nothing, no great. I mean, just I'm calling the proper library, right? And just I'm setting all of these things so that, you know, the complexity remains minimal. Basically, first, what we are trying to do is median income and median house value. Median income versus median house value is the first thing that we are trying to plot. The second is average rooms and median house value. That is the second thing that we are trying to plot. The third thing is latitudes and longitudes and the house value. Obviously, my target is to predict the house value, so I will be always plotting it against one variable versus house value. Right? Let me run this. Oops. Not scatter is not defined. Right. Now, let's first go to first one. And I have actually, I did put this chart into my PPT. Let's go back to PPT. And let's try to find out actually what we can find out from this chart. But this time I would like to brainstorm with you because this is something very basic. We have a lot of, some of you come from huge amount of experience from a lot of various backgrounds. So let's try to brainstorm actually what you are trying, what we are actually seeing in this chart. I'll go back to PPT. Right. I have already shown this, right? I'll hide it for the time being. Okay. So here it is that this x-axis, what it is showing, the income of the people. Income of people. And this is showing the y-axis is showing the house value, right? Obviously, you can also further go ahead and draw it into 4 quadrants. These 4 quadrants first. Right. Go ahead, right. Now, okay. There is a lot that this graph tells about consumer behavior. A lot. Right now, if you see, there is this is the fixed line that we have. The by pricing, this is the maximum. And these houses are very costly. But does it means that costly houses only high value incomes are going to purchase? No, actually, if you see about the behavior, this specific region is more dense here. And even it starts from here. So means here what we are seeing is low income, median income, high income individuals, right? And on this side, there is low income houses, low value houses, median value house, and high value house. Right? A lot of stories come from this thing. First being that, yes, high value doesn't mean that someone with really low income or median income, even someone with low income is going up with very high value. Right? If you see here, right, this, but this is the data points are less. But if you see the density around this from starting from this to this point, obviously, I did not zoom in a lot. We can go ahead and find a lot of, do a lot of analysis here. If you see around this area, people are buying houses, so it really doesn't depends on the income. Now, the most dense area is this. This is the most dense area. This is the most dense area. Now, this being the one of the most dense area, like I can extend it to this one also, like This is the most dense area. So basically, some comparatively upper higher ends versus, I mean, what people are trying to do here is whatever their income is, people are trying to buy houses somewhat better than their household income, right? And not just that, if you see, things are actually getting lesser dense here. I mean, people are actually not trying to buy really cheap houses. People usually tend to buy high priced houses. This tells one more thing about the mentality, that why house prices are increasing, you know, because people would usually like to go for high house prices as compared to low house prices. So these kind of behaviors, lot of behaviors, you know, we come up with, I came up with, I did write down some of them. So what happens? A higher median income usually correlates with higher median house. Yeah, obviously, I mean, someone is, this region is actually, I mean, people are not buying here in this region. Higher income people are not buying these houses. They're usually going with these houses, right? So this point is usually empty because they don't want to buy these houses. However, even medium income also don't want to buy like middle size houses, this side houses, because this area is again empty, right? A dense line at 500,000 is present, right? A dense line at somewhere here is present, 500,000 is present. 500,000 is here. 500 capped house appear value across a wide spectrum of median incomes. Yes. Many areas with modern median income show houses values at 500,000 cap prices. House value variance increases with income before reaching 500,000. This is the cap price, right? Median houses value maintain a baseline cost even at very low median incomes, right? Most data points cluster at lower to moderate income and corresponding houses value below the cap, right? So the whole point being that we come to know a lot about consumer behavior by looking at this data. Now, this is how banks actually trick you. They come up with their ads, like what kind of customer do we need to cater, who are watching televisions, who are on mobile phones, what income category do I need to target on. So all these kind of data, obviously, once you go on collecting, so you have this kind of data. Now, next is I plotted one more plot that was, now this is California housing. I plotted latitude and longitudes along with pricing. And you see it is exactly mapping the map of California. This is the map of California. So I just brought this into reference that this is exactly mapping the map of California. This is beach here, right? So the point being that these are the beach houses, or these are the green areas that are costly, right? While blue are kind of lower side income, right? Dark purple or blue, lower median houses. Now, if you see, it is not that all of the houses on the beach are costly. This not being the case. There are some houses here that are, I mean, okay. While most of the houses on the second layer, like that are somewhat away from the beach, are of somewhat median houses, and some of the median houses even occur in these areas, right? So this is how basically one kind of analysis we can perform. Now, the third analysis that we usually do is heat map analysis. And what is heat map? First and foremost thing, we need to understand what is a heat map. This is what heat map looks like. It is direct correlation of one variable to another variable. Right? We are directly correlating one variable to another variable. That is what is, now if you see on left hand side, right hand side, now obviously they will be correlated. This red means high correlation, blue means no inverse correlation, gray means no correlation, right?
and even it has a number also. Like 1 means obviously one variable will be exactly correlated to the same variable. So here we have, right? Now apart from that, what are the other variables that are highly correlated? This one, house value and income. Yes, this is related to 70%. 70% correlation is there. And mind it, this is linear correlation. There are ways using which you can also find the correlation that are not linear in nature. What do you mean by linear? So I say that, okay, this is linear correlation. What if they are correlated like this? That we'll have to make a different version of heat map. It doesn't comes ready-made. We'll have to work on custom things. Now, so okay, 0.69, and this is complete mirror image. So this part is mirror image of this part. So okay. Now, what is inversely related? This is inversely related. If you see, that is location. Latitude and longitudes are inversely related to my price, right? Then on top of that, we have average bedrooms that are very closely related, right? And I guess this is it. So now either what I can do is I can just select these parameters: median income, house age I can select, average bedrooms, and population I can leave because this is not at all. Average occupancy I can leave, latitude, longitude, and this is my target variable. I want to predict the house. So there was a question that how do we actually select what features? So this is one exercise that I have kept. Now, is this only exercise? Ideally, you will have to develop a greater taste for investigative numbers. There are a lot other ways. There are a lot other charts. As and when you go on experimenting with the things, it's a field where you have to get your hands dirty on it. When you start experimenting with it, you bring new problems, you start playing with new problems, you start seeing that some of the places there are relations, and then when it's tough to find out relationships, you can directly use deep learning to find any relationship. You can directly feed it into the model, right? And then model will itself tell you that if any relationship is present or not. So team, exciting or not? Right. Any doubts?
Anand, one, like in case if we will do ourselves in the free time and run the models, whatever you have given the
Right.
Colab files.
Correct.
Technically, if something's not run by us, right? Because then in that case, how we can get the help in that time? Like, is there any where we can get that in the Google or somewhere, or we can reach out to you in that case, or how?
Yes, you can always reach out to me. This is the whole point of running a mentorship program, right? On top of that, obviously, I will be solving problems without a doubt. You can first try to Google the issues. Now, workbook, what I'm giving, I'm testing them 2 to 3 times, so that no one lands into any kind of issues, at least due to library clashes. Because
Right.
library clashing is the most. I mean, you might feel that this is so big problem, but it is the most smallest problem, right? That so hence I want that nobody should be stuck in library issues at least. So I'm making sure that it should not happen. Apart from that, if you're facing any problem, obviously reach out to me. You start experimenting with the model, you start playing with the model. I mean, and if anything is broken down, obviously you don't need to worry about it. You can come back to me anytime. We will have on Sunday also, we'll have specific practical sessions. I'll give one more exercise book by tomorrow. So you have 2 exercise books. And tomorrow itself, you can start running in the classroom also, or you can, like, I'll give you the exercise book. I'll have to do some improvements in the exercise 2 book, and then I'll repost it again in the group. You can run it in your free time, and tomorrow maybe 4 to 5 you can ask the doubts. Does it make sense?
Yep, that would be helpful.
Anand, the Google Colab you shared in the group.
Yes.
So, like, if I do any change in that, is it going to affect everyone?
You'll have to copy it.
Okay, so I need to download it to my local and then do it, right?
Yes, you'll have to copy in your local.
Copy in the sense, like, there are two options, like download it as a Python file or download it as
No, don't do it. Don't do that. Don't do that.
Can you just
I'll show you.
Yeah.
I'll show you right now, right? Any other doubt, team? Okay. Like, once you get the notebook, so you just go for save a copy in Drive, so that you don't end up editing the same file.
Okay.
Right?
Yeah.
Great. Okay, here we have heat maps. Right? Point number 3, now we have managed the data. I have the data now. What do I need to do next? Once I have data, I need to basically split my data into like training and testing parts. And like I told you that this is the function. I have written this function here also, like splitting. Why do we need to split data? If we train and test our model on the same data, it might just memorize the answers for specific data and perform poorly on new data. Right? So it is very important to test always after your model has been trained, to test on unseen data on which it has not been trained. If you basically train it on the data that it has already learned, it will memorize and it will fool us, right? So it might say it is 100% accurate, but actually when we go ahead and run it somewhere, it might not be very accurate. Now, right. So what does it do? This function, it is doing that from sklearn model selection import, and then I just repeated this whole thing again. Basically, X and Y data. This is the whole story, right? I have explained it earlier also. And what is X data? X data means whatever the data we need to, the data that need to be mapped, and target is something that we need to predict. Right here now, if you see what was my X data, like even I crossed it on PPT also, although for training purpose I'm using all of the inputs as of now, but based on my correlation I could have ruled out some. But median income, house age, average rooms, average bedrooms, population, average occupation, latitude, longitude, these are my input parameters. And what will be my output parameter? Median house value. This is going to be my output parameter. I mean, I want to predict this housing thing, right? I want to predict this, right? Now, going forward, what we do is, I will go ahead and I am test size 0.20 means 80% for training and 20% for testing. Automatically, it will do this. 80% for training and 20% for testing. Great. And random state is basically so that my testing do not fall all of them in sequence, because usually when we will prepare the data, we might end up preparing them one after the another. So this is just for randomization, so that the model gets the random, and just I'll go ahead and run it. I'm done. Okay. And the next part. Okay. Now this here, it might seem as somewhat tougher part as compared to the previous one. Now, when I did show you this first program, it was as simple as just go for load digits and run the training, right? Sorry, load digits and just go for image classifier training. That's it. Now here, we have to, the first model that I created was basically automated, but here, what I'm trying to do, I'm trying to tell it that, okay, this is a regression problem. Regression, I repeat, regression, we had discussed earlier that regression is basically a process of finding relationship between two or more variables that may not be linearly correlated. Now, again, coming to the point, linear means when, let's say, if X increases, Y also increases. This is linear correlation, right? Inverse linear correlation is if X increases, Y decreases, right? So this is linear, inversely linear correlation. Let's say, when there is summers, the sale of air condition goes up. This is linear relationship. Or when there are summers, the sale of heaters go down. This is pure inverse. This is very simple. The whole theory is about finding relationship between two variables that are not linearly correlated to each other. Now, it can be that. How do I explain that? I'll have to find a right example. Although we are doing this example also, but I want to find a very common example in real life. If anyone is having any such example, they can also speak. I'll have to think in the meanwhile. Okay. Now this is regression. I'm trying to solve is regression. What is this mean squared error, and what is all this mean squared error, right? I'll come back to it. Don't worry about it. I will be explaining these errors in very detail. Now, basically what we have done, now you remember there is an input produces an output is compared to real value, the truth source. And then what is a delta? Delta is the error. There are few ways of calculating the error. As of now, what it is saying, square the error. Let's say if the difference between them is 2, do it 4. If it is -2, even then do it 4. By squaring it, it becomes 4, right? So basically, whatever it is, basically we are trying to square it. This is mean absolute error. It means as it is. But don't worry, we have a separate session for it because we'll be discussing them. There are various kinds of errors we have. We'll be discussing all those kinds of errors. For now, there is an input node here. This input node simply tells that what is the shape of my input. Shape means what is the dimension, because I need to initialize how many input neurons do I need to make. The input shape is 8 basically. If you see here, if I run it, input shape is 8, right? I can directly go ahead and write 8 also. But just in case I can go ahead and do this also. This also works. Yeah, these things are, I'll have to just enclose it in proper shape variable. This thing also works. So the whole point being, yes, here I'm trying to tell that this is my input. I have to specify what is my input so that my number of input neurons are made. And then I'll have to tell what do I need in the output, right? I'm telling that in output, basically, I need something, regression. Basically, regression means I need to find out the relationship between these two. And that's it. After configuring this, what I do is I say that, okay, auto model, I'm not taking care of anything in between number of neurons, what is the arrangement of neurons, what it is, max number of trials I want to tell, right? I want to tell it max number of trials, 5. Ideally, it is 100 by default if you do not give it, right? So 100 is going to take huge amount of time. As of now, I'll just take 5 because even this 5 will take some 5 to 10 minutes because this is a simpler example. As I go with any image classification or any such problem, such kind of problems is going to take some amount of time. So, okay, and then I go for overwrite is equal to true, right? Overwrite true, why? Because every time I want that my previous configuration should be overwritten, right? Previous configuration is present should be overwritten. And that's it, team. And my configuration is done. Now, I have prepared data frame for visualization purpose. I need to convert them back into a type that runs most efficient on my CPUs or my GPUs. And that is basically called as NumPy. NumPy is basically, I mean, it is nothing fancy. Basically, if you see a lot of time, what we will be doing is a lot of time in AI, we will be moving data from one type to another type. You might say that, but this is actually 30% of AI is this. The reason being sometimes you need to, we need to optimize data types so that they run on GPU or CPU. As of in our case, we are using CPU. We have yet not jumped on GPU, right? Now, I think everyone has heard about GPUs, right? The GPU war that is going on, isn't it? The NVIDIA, I mean, NVIDIA is the single winner as of now, right? And now we have few players coming from China, you know. So all of this war is real, and you can optimize. I mean, you can save a lot of money. Now, basically, what happens if I send my data frame in CPU? Is it not going to run? It's going to run, or GPU, right? Same data type, right? Same data type will not run optimally. That is, it is going to slow down, and the, slowing down means money, right? When these models, you are going to run it overnight. Let's say some model takes 12 hours on data frame. On NumPy, it might reduce to 2 to 3 hours. Such is the huge difference. Even as of now, we are doing all of this AI on Python. C++ is at least 6 to 7 times more faster than Python. Right? Python is the slowest language. It is the slowest language in the world, but it is more closer to English, and hence we are doing all of this. You see, it is as simple as that. That train, you need to NumPy. That's it. Change to NumPy. Finished. You need to change to data frame. Just call it dot frame, and it's changed to data frame. So this is very close to English, and this is the reason it has got so high amount of adoption, obviously. But yeah, I mean, usually what happens, either there are cases where we can convert our Python model into C++ models also. So there are libraries available for it, right? So we need to convert it into NumPy. You might be thinking that, okay, you are doing all of these things in that image example. We did not do, because we did not create a data frame for that. Hence, we do not. So this data frame was just created for those visualization purpose. And last point is fit. 20 epochs with the validation split of okay, validation split here also I'm specifying. This is 15% of validation split, right? Validation 20 epochs, 20 rounds, right? 20 rounds of training that I need to do, and I can just start. And my max trial was five trials, right? I need to test it for 5 trials. There is some error again here. And array with clause. Expected target data progression to be dataset. mp.nd target trained. Okay, so it has started running. You see all of those things: hyperparameter, optimizer, learning rate, gradient descent algorithm is Adam. So we'll discuss on these things. It is automatically selecting all of these things. I don't have to do anything. Now it is running trial 2. Learning rate has changed maybe. Validation loss is very poor as of now. I mean, in 20 epochs, nothing is going to do anything better. This is first exercise is just for the sake of running. In second exercise, I will share how to get the best output from this housing data set, right? First, we just have, for this exercise, we are just learning how to make models. Then we will see how to optimize basically our exercise for best output. Right, now it is trial number 5. And automatically it will select the best model. Okay, I guess this is finished. And last is basically, now what I will do is I will give it to evaluate that what has been my overall accuracy and everything. Like here again, I get some error. Serializable. Okay. I guess this function will not run. I'll have to retrain the model. It is asking for one more configuration that I should have added earlier. But anyways. Right. So I'll come back first to this model. Right. So what it has done, it has validation loss has completed. And then what it did was basically the best model, whatever was present, it was able to save that model. And this is the model that it did choose. Right? It was able to choose the best model. I mean, this model isn't very optimal because we just trained it on 20 epochs, just 5 trials, and we did not even select the features. So, I mean, this is not going to be very optimized version of the model. But yes, what we did was we created our first model. Now, when I give you the, this is again because of the library clashes. I mean, this specific library version of the library is not supporting this function right away. But anyways, I'll give you the right version. Don't worry. So when you run this exercise 3, either give me 1 hour or so. Although everything is fixed almost, I just need to put the right libraries, and everything here has been taken care apart from that. Right. Now the same goes for even, I will just show you.
Even when I was trying to run this example, the same process I'm going to follow. But here I will just go for one epoch. Now don't expect it to do wonders, because I mean, we're just running on one epoch and 2 trials, right? It started with trial 1 and we'll let it finish. In the meanwhile, we'll let it finish and we'll just discuss some small points. So, okay, this has begun. If you see, this has started. Okay. Now, what did we see today? Now, basically, we did see that what was happening here, that we had a model, right? Okay, I'm not sharing, I guess. Okay. So we had input data. And from this input data, what we did load our data from Scikit-learn, right? As of now, for simplicity, for few sessions, we will load automated data that is already present. And then the second after loading, we split the data. And then after that, we visualized it. This was part 1. Once you have done this, what you need to do is you just need to pass on the data to the model. You just create using AutoKeras. You create a model and you pass it on. You pass this model. And as you pass this model, it will automatically start running, auto run. And in the last, once you see that, okay, this model is satisfied, you can save the model. You can zip it and keep it with you. Now, whenever you want, if you want to run it somewhere else, you can take this model, load the model, the zipped model, load model, and you can either attach it with any Flask API or something, and you can run it. I mean, this is for simple models. However, when we are exposing it to, I mean, when you are a big company, you're exposing it to a lot of people, obviously, then you will have to attach high availability frameworks and everything, high availability frameworks. Like, now, I hope this whole cycle is clear. Is it clear? Great. Was it difficult? I hope it was not difficult.
That's difficult, but practice is required.
Yes, you'll have to go through that exercise that I have given you. In the meanwhile, if we go towards our model, what is the state of our model? Here is my model that is still running. What it even try? Okay, trial 2 is running. Trial 1 has finished. Now, how do we save the model? We can simply go ahead. This is one line function. Save. Now, best model, where did it come from? Whatever the regression variable we had, dot export model, right? And from here itself, I was showing the summary of the model. In summary of the model, we can see it it has 8 neurons in the first layer, then it has another 8 neurons, and in last output neuron is 1 neuron. So this is very simplified architecture. I mean, dead simplified. I mean, just like the one architecture that we were seeing. Can we make this architecture ourselves? Yes, obviously. I mean, not a big deal out of it, but we are just trying to learn it step by step, because I don't want we jump onto complex things altogether. It is still running such small model, such small things, but still running. Accuracy is 29% in this case, which is very poor. I did run it with actually 5 trials and 50 epochs. So I was able to reach till accuracy of 90%. But yes, you will have to let it keep running for around what? At least 1 hour. Accuracy has increased to 87%, which is impressive on this small data set. Okay. Now team, let it finish. In the meanwhile, I'll give you the next steps that you have to do now. This is your notebook. I will fix this line. I'll have to fix this line so that all of the versions are in place and you don't have to struggle like I was struggling. So as of now, you just have to go click, click. There are certain fill in the blanks like this one. This is one. I just have kept 2 fill-ins as of now. In future, as you go, you will have multiple fill-ins. This is one. I guess I have just one. Right, you just have to run it and at least try to read this. This function I was able to run in previous libraries. So I'll fix this library thing so that you get this thing. Now, so in regression versus classification. In classification, we usually get the accuracy, but in regression, what is happening? Basically, we are getting mean squared error and mean absolute error. These kind of things we are getting. Right. So we are getting mean squared error and mean. Now, basically, mean absolute error lower, MA is better. But yes, in our case, this is very high, and this is also very high. So obviously, this is not a good performing model, right? So try to run and then try to do the predictions. Try to save the model. This model will be one folder. You can zip it off. You can right click and zip. It will be just one folder. Pick this one. You can just go ahead and then you can download the folder. And then when you want to reload this model, you can just go ahead and load this model once again. And once your model is loaded, you can start doing the predictions. You can start doing these predictions. What is this, right? So I'll just quickly explain you what this is. Let's say you have any array. Everything that we deal in AI is going to be one-dimensional array, or it can be 1, 2, 3, 4, or it is going to be a matrix, right? Like a kind of 1, 2, 3, 4, and then 4, 5, 6, 7, something like that, right? Either of this ways. Now, basically, most of the data is going to be two-dimensional data. So if I have this array is equal to 1, 2, 3, 4, I can just access it as A of 1, 2, 0, 2, 3. So it will give me first 3 elements. This is slicing function. 1 to 2, only 1 element, right? Or 1 to 5, 5 is not there. 1 to 4, 2, 3, 4. So this is slicing function. It just means which window we need to give. That's it. And here, I guess, again, so the problem with this setup here is that I'm using a different version of AutoKeras, which I did notice in the starting, but it was able to run the training. But once I try to do the predictions, it is giving me an error. But this won't be the case with you. When I give you, I'll give you a well-tested notebook. And once you run this prediction, you will be able to see this prediction like this. So next, wait for maybe 30, 40 or 40 minutes, and I'll give you an updated notebook in the group. Any other doubts does anyone has? No doubts?
No, sir, I have few doubts.
Yeah, please let me know.
Okay, so this is about the validation techniques. Here we have used the splitting one, but there are some other validation techniques like k-fold, cross validation, and all. So basically, those are we choose is based on the size of data and So, so my doubt is like, is there any specific range from where we say that yes, this is a small scale data, or this is enough of the data, and then we can choose that particular validation technique for the better performance. Like usually we say if we have the millions of records, and then this is enough of the data for the model training. But I mean, I just want to know is there any cutoff line, any range from where we say that, okay, this is the small data and this is the enough larger data?
See, depending on the complexity of the problem, let's say if you are dealing with this problem, price prediction, then few thousand of data is enough, right? But if you are dealing with, let's say, text generation problem or LLM problem, right? Then obviously the data size for initial training will at least have to be few 10,000s. Because is there any rule? There is any not established rule, but I'll give you a thumb rule around it. Okay? Since I did explain you today that what we did today was we did see that, okay, we have these neurons and these neurons are trying to establish any weights and everything. Now, the point being, the more complex data is, the more weights it will need, right?
more understanding, more pathways it will need. So more weights it is going to need. Now more weights means bigger the model you will have to do it, and bigger the data also. Because now obviously if you have lot of data but your model is too small, it is not going to learn all of it. Right? Similarly, if your model is too huge but your data is too small, again, I mean, that is not going to fit. Now, is there any specific number? There isn't any specific number around it. I mean, we have to find out along with the problem. We'll have to go with the problem. We'll have to play with few experimentation techniques. I mean, like AutoML and anything. AutoML is really good for initial experimentation. Then we can establish that, okay, this data is going ahead. Now, talking about validations, I did not touch the topic as of now yet, because again, that might again confuse everyone. So I will be covering that topic, but in a different way. Like, I mean, what are confusion matrices, and how we can validate the data? What are the different ways you can evaluate all of the output that we have? As of now, we'll just concentrate on building of the model. Once that part we have conquered, then we'll go to the part 2, that is understanding the output and basically evaluating the output. Right? I hope my answer makes sense.
Yeah. I mean, I understand it was not about the validation techniques, but it was about the size of the data. Like
Size
from where.
Yes. In your mind, initially, like you might face some struggle, but as you go on practicing with more problems, you'll find that, okay, this is LLM, and the problem you are teaching to LLM is, now let's say you want to teach a very simple problem to LLM, that sentiment detection. IMDb, a user has commented something, you want to find out that it is positive, negative, neutral, or anything. It's a simple problem. You will need very less data for it. Right? Because now just imagine, it's easier for it to teach. Now you want to teach a mathematical solving steps to LLM. You are going to need a hell lot of data for it.
Yeah. So
Right?
it's not about LLM. I understand for LLM we need a larger data, but it's for the models which are available in the deep learning.
The rule is same for everyone.
Okay.
LLMs are also the models, similar kind of models, right? Just with attention network. Right? So the rule goes same for everyone. The more amount of pathways a model has to learn, it has to come up with more data and more bigger model. And hence people are coming up with LLMs, 100 billion LLMs, 200 billion LLMs, and so on. Okay. Because they're trying to dump huge amount of logics into the model. They wanted to learn maths, medics, legal, and everything they wanted to do. Now, if you concentrate just on legal or medics or maths, a smaller model will do. And hence there was also a question about small language models. So same goes for small language models, will definitely perform better on smaller amount of use cases.
Yes, right.
Right.
Yeah.
Anything else, team? Great. In that case, can we wrap this session now?
Yes.
Yeah, great. So I'll give you a small this sheet. And I recommend that kindly finish this sheet by tomorrow. Tomorrow we begin with more topics, with more visualizations. Obviously, we'll be repeating things, and we'll be going one more deeper. We'll be covering one more model. Basically, we'll try to go with image classification itself, full-fledged image classification, right? And then we will jump onto a new topic, that is, we'll start with understanding of how do we use PyTorch, because any advanced models as of now, they all are using PyTorch. They're not using AutoML or something. So this was just to get you started with how to make models, but you will have to start practicing. I mean, at the end, they all are models only,
but we'll have to start with PyTorch because Hugging Face is based on PyTorch. All of the modern LLMs, everything is now on PyTorch. So we'll have to learn the basics of PyTorch. Is it tough? No, it is not tough, right? Again, I'm repeating the same thing. There is not much of coding in AI. It is more of an artwork. So just get your hands dirty on it. Initially, you will stumble upon a lot of library issues. Don't worry, I'm here to solve them, right? So don't worry about it. Just keep on practicing. Use Gemini or use ChatGPT, whatever you are comfortable with. Go Pilot, whatever you are available on, free to use. Use them. Generate codes, write some codes. Try to do all sort of experimentation, and you'll see you are very confident very soon. Right, team? All right. Then bye. Have a very wonderful evening, and I'll catch you tomorrow. Bye.
Thanks,
Thank you.
Anand.
Bye.
Thank you.